So if you would, please help me welcome Marissa Mayer.
Good morning. I left Taiwan last night at 11:10 p.m. and arrived here at 7:30 p.m., 4 hours earlier. The international dateline is actually pretty tough to beat in terms of latency and user experience, but that's what my talk this morning is about. How to make the user experience faster through design, through observation, through metrics. Because at Google, we really are in search of a better, faster, stronger web. And when people think about the speed of Google, a lot of times they think about our homepage. That very first impression. This is the homepage as it appeared in 1999. And people ask me all the time, because I've been in charge of the homepage now for about 10 years, why did you do it this way? Is it a statement towards minimalism? Was it a statement against all the clutter that existed on the web in 1999? Was it about the singular focus? Was it about speed? And I can't answer that, because I actually didn't do the original design. I've just been the keeper of it. So I asked Sergey, this is Sergey at Web 2.0, having crashed his way into another O'Reilly conference and onto the stage. When I asked Sergey this question, why did you design this minimalist homepage the way you did? People ask me this all the time. Sergey looked at me and said, we didn't have any webmasters, and then added with disdain, and I don't do HTML. So that's why we kind of stumbled into our signature look. That clean, simple homepage, it really wasn't by design. But that said, it really has come to signify the simplicity that's Google and also the speed that's Google, which is why today things are still simple and still fast on Google. And I have to say that while my talk today is going to focus on the front ends and the designs that we roll out, it is really important to recognize that the back ends are also really fast. There's 4 key elements in a search experience. Comprehensiveness. We have to have all of the content on the web so we can find the best possible answer out there. After we search those elements, we need to be able to rank them. This is where relevancy comes in. How do you take the web pages that really fulfill a query and rank them in order of importance and accuracy for the user's query? The overall user experience, how does it feel? How does it look? How does it work? And finally, speed. Speed is really important. And when you look at Google's infrastructure, we really have built throughout time to be very committed for speed. It's interesting, today's June 24th. I started at Google 10 years and 1 day ago on June 23rd, 1999. And on the first day that I was there, our web index was 30 million web pages. And today, it's 10,000 times that. Right, 300 billion pages out on the web to search. And remember, every time we add a web page to the index, it means that we have to work that much harder, right? It's a linear relationship in terms of actually being able to search that content, or at least it should be a linear relationship. In terms of the searches done per day, we were doing a few 100,000 searches each day. And now we're doing approximately 10,000 times that. So, and again, each time you get another search, that's just a little bit more work you have to do. So when you think about the scale that Google has operated on and has evolved on over the past 10 years, it's really a factor of 10,000 times the content and 10,000 times the amount of searches being done, which really is a factor of 100 million times. And so if you think of the Google search engine as an engine like there would be in a car or a steam engine, it's an engine that today works 100 million times harder than it did just 10 years ago. And that's a huge testimony to the search engineers, the way they've optimized the system and really been committed to speed. Because that first day that I started in 1999, they said, our goal is to get search results to our users in under half a second. And today, despite the fact that the engine is working 100 million times harder, we still try and get our results to our users in less than half a second. So given that our engineers are doing all this beautiful and amazing work on the back end, how do we design for a front end that really showcases that and respects that? How do you design a front end that really highlights the type of speed of less than half a second, a third of a second, and so on? So at Google, we do something called split A/B testing, where you randomly select groups of users and give them a different experience to see how they respond to it. Something we've done for a really long time, and one of the very first experiments that we did was on the number of results. So, Larry and Sergey asked me to work on user experience after I'd been at Google for about 6 months, and they said, just test things that we don't know a lot about, arbitrary decisions we made. And they were like the number of results. We picked 10 because Alta Vista did 10, but Yahoo has 20, maybe we should offer 20, right? Maybe it should be 25, maybe it should be 30. Pick a number and prove that it's the right number. And I said, okay, so I went and I had a user study, and I asked all the user study participants, how many results do you think should be on your results page by default? 10? Sure. 20? Even better. 25? Better yet. 30? Best of all. So it was unanimous. All the user study participants said they wanted more results. We ran the study, and in the worst case, the 30 results by default case, we saw 25% fewer searches in less than 6 weeks. Why? We had lots of hypotheses. Was it the paradox of choice? Is it the fact that these users just were confronted with so much information they didn't know what to do? Maybe it was the fact that because they were getting more results on that first result page, they weren't clicking next and they weren't doing those searches. But no, it turns out first result page searches were actually down 25% over 6 weeks. And remember, the Google search business generates about $10 billion a year right now. So if you reflect back, that's a decision that ultimately could generate or swing $2.5 billion annually. So we were really quite frustrated because it didn't seem, while we had all these hypotheses, it didn't seem like we actually had one that could explain something so powerfully. So I just ran a regression. This was back when I was doing more engineering and coding. I ran a regression over our logs. There's about a dozen fields or so, and I just ran a blind regression to try and understand which field showed the most variation between the control and the experiment. Was there a selection bias? Was there something that wasn't obvious? And sure enough, there was one field where there was a really big difference between the control and the experiment in terms of the regression. And that was speed. It takes us longer to compute 30 results than it does to take 10 results. And while the users thought they wanted more results, they weren't able to articulate how they would trade that off in relationship to speed. In fact, it takes us about a half a second longer. It took us about 0.4 seconds in that particular control group to do 10 results. And it takes 0.9 seconds to do 30. So that half a second could cost us as much as 25% fewer searches, which is a really huge swing in terms of overall usage and traffic volume. But of course, this wasn't a perfect experiment because we haven't controlled for all variables, right? There's a different number of results on the front page. It's possible that some of the decline was because they're getting more results. So we ran a different test. We ran a test where the only thing that was different was how long the search took. So we took our regular search and we just injected a delay of 400 milliseconds to see what would happen. And searches per user decreased by 0.5%. Over 6 weeks, they were down 0.75%, and it was clear it was going to be a linear trend. These were smaller than the numbers we had seen on the earlier experiment, but still significant, still several hundreds of millions of dollars a year in lost searches. And what was worse is once we saw this detrimental effect and we turned off this experiment, the users continued to search less. They still searched less by 0.25%, and statistically significantly so in all of these measures for the remainder of the time that we monitored them. So it's clear that latency really does matter to users. Whether or not they can articulate it, they really do use it to decide which products to use, how to use them, and how frequently to use them in a really meaningful way that impacts them throughout time, even after a delay or latency has disappeared, which we thought was pretty interesting. So I wanted to now turn to looking at a few case studies, things that we've done on Google that have sped things up, and sort of what types of things we've seen there. So the first is Google Reader. This was the Google Reader design as it appeared last year. How many people here use Google Reader? Hopefully some. Okay, and so this was what Google Reader looked like all of last year. And then around January of this year, we rolled out this design. Doesn't look that different, right? If you look at it again, like there's some background colors that go away, shifts a little bit. But that was the change that we made in January. And interestingly, in our user studies, people said, it feels lighter, feels cleaner, it feels faster. Faster was one of the key words that they used to describe it. And in fact, they were right. It is faster. You can see this is when we shifted our traffic over to use the new reader design. Google Reader is faster. And to talk about why, I have to tell you about one of my observations about HTML and design, and it's one that my design team thought was so funny. They've had printed on t-shirts, one of which I have on now. And so my observation is that HTML wants to be square. Basically, if you look at HTML, it's very easy to get a shape on the web that's square. And if you try and round anything, round corners, you need to either use CSS or images. In fact, I have a standing challenge to designers to show me a rounded corner that can be achieved in fewer bytes or in less load time than a square corner. And over the past few years, and I'll open it up to the group today, it just can't be done. Because at its essence, HTML was designed to be square. And of course, the team thinks it's really funny because it's kind of absurd that HTML would actually have an opinion on the matter. But HTML does really want to be square. And when you respect that and you look at some of the properties in it in terms of how many bytes do you need to actually achieve a particular design, it's really clear. And so small changes like that really can make a big difference. You can see this is what happened to Reader's 7-day actives as we released the amount. The dip in the middle is actually Christmas. They rolled it out over Christmas and the New Year. So you can see our 7-day actives went up. They went up a lot, and they stayed up because the site was faster and people responded to that. This is Google Checkout. And when we released Google Checkout, we were very excited about it. And we decided that we should mark some of our advertisements, the advertisements that were in fact offered by people who accepted Google Checkout with the little Google Checkout icon, the cart. So we put the cart on the page and loaded it up, and latency increased by 2%. And searches per user went down by 2%. Why? Because browsers are not very good at handling images. Right? Our designers were really frustrated by this. They said, but it's such a little image. How can it make such a big difference? And it's because when you actually have an image, you're opening up another connection on the side of the connection you already have open for the web page. And the connection's really expensive. Right? I tell them, think about it as if a small image costs $1 and a big image costs $1 and a penny. Because the connection is really what costs you the extra time. So we challenged them. And said, is there a way that you could mark the checkout advertisers without an image? So we tried some textual badges. We tried some other things. People weren't as happy with that. So they came up with this. They actually figured out a way to draw the Google Checkout cart using HTML, in a table, using pixels. And it turns out it renders just fine. Looks like that. It's shrunken down to a pixel-by-pixel level. Looks just like the Google Checkout cart. And you think, but that's absurd. Look at all that HTML. How can that render faster than an external image? But in fact, it does. It does render faster. And when we put that block of HTML into our results page, we didn't see the decline in usage that we saw when we put the image there. Of course, today we've even done better than that because now we have a sprite running on our search results page that actually has the cart and the badge in it, so we just load one big image and then cut it up using JavaScript. But it's really interesting to think about how images, how some of these HTML elements can really impact your user's perception of speed. So the next one I wanted to take a look at is Google News. So this is Google News. As you can tell, it's a really rich and complicated page. And it's actually quite a monster of a page. It takes about 8 seconds to load Google News in full. That really surprises Google News users. How many people here have used Google News? It tends to surprise Google News users because Google News feels faster than that. So how does it work? As you can see, it is a big monster of a page. It has about 27 images on it, all of which are dynamic and change all the time. The headlines are dynamic and change all the time. And in total, the page is about 80K. So there's not a lot of caching help that can work here. And the interesting thing here is HTML tables. Tables have this nasty property that, well, they're very flexible, and you can load up all the content trying to determine what the different rows and heights will be and the column widths will be. They often don't render until the very end. They do what I would call a flash render, which is they get all the content, they're trying to figure out the sizes of the different columns and the different rows, but they can't size anything until they receive the closed table tag, which means if we rendered this whole page to be pixel perfect in one lockstep design, it would wait until it got all the content at the end and then flash render it, which means you'd wait the full 8 seconds until you had anything on your page. what we did instead is we've chopped it into smaller blocks of HTML. So basically, the table structure of the page looks like this. So you can see that we've done some things that aren't great, because like lower on the page, we'll have two side-by-side sections like entertainment and sports, the left column and the right column, and we table them together in a chunk, which means if one is taller than the other, it doesn't render quite perfectly. But we'll take that because it's that much faster. Because then what ultimately happens is each table is received and loads, and the whole page actually loads as each of those tables closes up and can be sized. Which means that you actually have content above the fold in under a second, and you can interact and look at and read that while the rest of the page takes about 8 seconds to load. So smart tabling in terms of the HTML is actually really powerful. And there's actually more tables and tricks on our search results page. In about 2000, Larry and Sergey came to me and they said, we're running these ads on the top of the page, and we really want to put some ads on the right-hand side of the page. But we can't figure out how to do it without tabling the entire page. And if you look at all of our competition, everyone's running a table structure over the whole page, does this terrible kind of flash render at the end. Is there any way we can do it and have Google still be fast? So I looked and I spent a bunch of time reading through the W3C docs and trying to figure out were there any HTML tags that could help us do that, so we wouldn't have to table the whole page. And sure enough, I found one. I called the $1 billion HTML tag at this point, given the revenue that the right-hand side generates. But this is how the search results page loads now in terms of giving users a lot of speed. We load this top part of the page in its own chunk using chunked encoding. And if you look at this, what we do is we've designed the top of the page so there's nothing specific to your result set above that line. We know what your query is. We can just echo that back. The Google logo, those links, those are all the same on any results page. So we can send you that chunk while we're actually computing the results. We don't have any of the results back before we send that. So the top of the page loads up. Then we hand this next piece off that tells you the total number of results and the seconds as that comes back from the back ends. And then, this is the tag that I found, we can create a table, which is this column table here, using a table align equals right tag, which means that table, that column of ads on the right-hand side, is an independent table, and we don't need to have a table tag running over the whole page. We can actually just have a table on the right-hand side and close that table right there. So that part of the HTML appears first, and that is the insight. It's a tiny little thing in HTML. It's not anything groundbreaking, but it's really amazing in terms of what it opened up, in terms of us being able to keep the page fast while opening up many more spots for advertisements and a lot more competition in our auction. And then once we've rendered that table, you actually insert that full table. All those ads appear before our results if you look at the HTML source on the page. We go on and we happily render the top ads, the search results, etc. And if you've ever used Google on a slow connection, that's actually, this order is roughly what the page loads like. You see the top load, you see this next piece come in, you get the ads on the right, and then you see it slowly populate its way down the page. So it's really interesting to think about how can you look at the HTML structure of a page, how can you make your site be fast, and how can you use some of these different specifications that are built into the language in new and interesting ways in terms of chunked encodings or different types of table tags to really get the sense of speed. And the last case study I wanted to take a look at is Google Maps. So about 12% of Google Maps users access the internet using slow connections. And so the Maps team saw this and they said, what can we do? Because Maps, unlike news, can't really be helped a lot by table structures. It's not quite like the search results page. Is there anything we can do? It's a very image-rich site. It's a dynamic set of images. We need to open up a lot of connections. Is there anything we can do? And they basically started thinking about compression. And they realized right away that maps compress pretty well. It turns out if you compress a map tile, you can get it down to about half its size. And it turns out the satellite imagery compresses even better. It compresses down to about a third of its size. So sure enough, we released this new improved compression and achieved an improvement of 2 to 3x on the site. And usage went up. This is the panning and zooming activity of users who received this new compressed technology. And you can see right away how users respond, how they responded to this technology. So in terms of designing for speed, what are the key tips? One, that HTML wants to be square. I love rounded corners as much as the next person does, but if it actually costs usage and ultimately costs revenue, it's really something that often can be changed, tweaked, and refined, so you get something that's still really pleasing in terms of a design, but works better and loads faster. Images 101, small images cost $1, big images cost $1 and a penny. Like, try and be smart about images, sprite where you can. Tables are purely evil. You need to think about how you're using tables, because the flash rendering really does change the way that the page loads, and compression is your friend. So now looking more broadly at speeding up the web. Speeding up the web is something that Google cares a lot about. We've been really happy in the last day to announce a large set of initiatives, including page speed, which many of you saw yesterday, and a new site at code.google.com/speed, where you can see a set of tech talks on the different tools and techniques that we use at Google in order to try and make our sites faster, and some of those techniques that we think will scale well to other websites. Because our goal really is to try and make browsing the web as fast as browsing a magazine. What would it feel like if all of the content on the page you were about to click through to was already loaded, and clicking on a page actually felt more like turning a page of a magazine? We think people would use the web a lot more. And certainly that is something that we think makes the web ecosystem better. It's also something that serves our interest, because we think when people use the web more, they do more search. So our goal really is to make the web ecosystem as a whole better and faster for users. That's why we're investing in building things like Google Chrome, which really focuses on speed, particularly on JavaScript pages, to try and make using the web a better, faster, more pleasurable experience. So today I've talked about building, designing, and prescribing for speed. How can you build a backend that scales and stays really, really fast? How can you design, through interesting HTML tricks and observations and measurements, sites that actually load much faster for your users? And how can you prescribe for speed, encouraging your users to use tools that ultimately will make their experience faster? You know from the HTTP on the user agent on your web server when someone's using an antiquated or a slow browser. Tell them to use Safari or Chrome or Firefox or a faster browser overall. Because we really think that if the web gets better and the web gets faster, it's good for everyone. And with that, I have some time for questions. So there's some microphones actually here and here, or you can just shout it out and I'll just repeat it. Okay. Yes, there definitely is. So the question is about Google Web Toolkit and how do we look at different measurements and metrics and some of these tools in order to optimize that. And we definitely do. Because developers use Google Web Toolkit in order to build their sites and optimize their sites, it's really important to us that we turn out HTML, JavaScript that is as optimized for the web and for different browsers. And so they look at that quite a bit. New releases of GWT often actually improve in benchmarks the previous release.
Hey, nice talk, thank you. So the results about having more results per page is very surprising to me, because I personally always customize my page to have more results. And I do have less searches, but the reason I have less searches is because the result I'm looking for is already found within the longer page. So the comment I'm trying to make is, so why do we think that always less searches is better? So, is actually worse. Sometimes less searches is better. Right?
Well, it is, except that when we did control for that in that experiment. So at first we thought, well, maybe it is because they don't have to go to the next page as often. But even on first page searches, we still saw the decline, and it was as sharp as in searches overall. So I think that the lesson I really took from that is that a lot of times people's prescribed behavior is different than their described behavior. So meaning that what people think they actually want is different than what they'll actually do when presented with that. Because it's very hard for a user to understand how they're going to trade off speed. So certainly there will be some anomalies, some people who really want more results and are willing to make that latency trade-off. But in large majority, what we've seen with our users is that people will respond better to the faster speed rather than the additional results.
So this is kind of a cultural, organizational question. Obviously Google does a lot of performance tweaks to make pages really fast. But can you comment on how you instill that desire across the entire organization, across the development teams? And then also I mentioned earlier the difficulty people are having in finding developers who are skilled in this area. Do you have any comments on how Google addresses that dearth of talent out there?
Sure. Well, I think that it really comes, at Google it started very early. I remember when I was coding on the front end, I remember having arguments with Craig Silverstein, who did my code reviews on the Google web server, about each and every character we put into the HTML, right? Like, could that be shorter? Could that be more concise? Every byte mattered in terms of the overall speed. And I think that's been there from the beginning. But that said, I do think that having interesting case studies, pointing to interesting examples where people have actually seen usage go up. Because when usage goes up, everyone wins. And so if you can actually point at that, be it in your company or somewhere else, that's a really strong incentive for people throughout the organization, to design and think about speed. And I think it's kind of apparent that I know that even down to our design team, they've really embraced the concept that everyone's efforts on this matter, be it software engineers, site reliability engineers, designers. It really is something that pervades the culture because there are real results attached to it. And in terms of finding people who have this skill and are good at this, a lot of times they are made, not born, right? So what we've really seen is that, at Google, a lot of people will come in and they need to be sort of given, shown the ropes on images, HTML, a lot of the different things I've talked about today. But the good news is that the rules are reasonably simple, and it is pretty straightforward to understand and optimize. So, with some pointers and people who are willing to share their time, it's usually something that we've overcome reasonably quickly.
I had a related question on organization. So is performance really the mandate of the product management team? Is it developers? Is it operations? Is it QA? What's your sense for which of these different groups are the ones that really care most about it today at Google?
I really think that it doesn't stand out in any one group in my mind. All of them are equally committed, right? Product managers ultimately want more users and want more usage, and reduced latency can get that, right? If you tell the Gmail team or you tell the Google Reader team to get 20% more traffic next quarter, coming up with a feature that's going to do that is reasonably hard. Coming up with optimizations that can do that is reasonably easy. If you can actually cut down your load time by 20 or 30%, you'll probably get that uplift. So that means that product managers are incented that way, engineers who want to see their product be more successful are incented that way, the quality assurance folks. Also, I think that common goal of having more users and more usage and the way that latency fulfills it in a way that is very hard to fulfill it with other features really means that it's everyone's mandate throughout the organization. It's not a single group that's left to pick up that charge. So yeah, there's another question over here.
Hi, I was curious about your optimizations you did for tables earlier. I was wondering if you'd ever tried using proper semantic markup and CSS instead of tables for layout, and if that affected performance, considering usually it's less code and renders a little faster.
Sure. In fact, we have. And basically what we've seen is that CSS in most browsers is implemented using JavaScript and client-side technology. And what you see in a lot of cases is that users' computers are slower. So if you actually put a timer on the page to understand when the rendering is completed, if you use the CSS, it's slightly slower. So we still have had that open challenge of, can we design a rounded corner that loads as fast as a square corner? And we haven't found one yet. We'd eagerly await an advance that could yield that, but we haven't seen it to date.
Well, I wasn't talking necessarily about just rounded corners, but the Google search results page, which has no rounded corners. But anyway.
Yeah, well, we've also looked at different JavaScript techniques too, in terms of loading the page differently, keeping some of it cached, and there's certainly some optimizations that can be had there, and we're experimenting with those.
Hi there. How do you see Google balancing the top-down versus bottom-up leadership? For example, you have the 10 things philosophy page. Sounds very top-down, and how did that contribute to your success as a performance engineer?
I think that it's interesting. The genesis of the 10 things page was actually bottoms up. It was written by Googlers who were trying to capture some of the elements of the culture in those observations. And so it actually, while it might feel very top-down, is actually very bottoms-up and came from within the organization. I think which is a really strong testimony to the initiative of people there and also the strength of the culture. And I think that it is always a balance and with top-down and bottoms-up. But that said, we have respect for the fact that good ideas come from everywhere. They sometimes come from our users, sometimes they even come externally, and so we try and develop forums that can listen to all of that different feedback from our users, from developers, from advertisers, and from our employees at all levels of the company.
I think if I propose to my management replacing a prominent icon on our webpage with an HTML table, they might laugh. What does it say about Google's management that they take that kind of thing seriously?
I don't know. I mean, I have to say, the HTML table was, pretty shocking when they came into my office hours with it. They were like, we've found a way to render our table using HTML. I don't know. I mean, I think that results really speak. So, I mean, I was sort of taken aback at first, too, that the fact that this big blob of HTML, would it actually load more quickly or not? And then they actually demonstrated in our latency lab that it does load faster, and it doesn't slow down the page the way an external connection for an image would. And so I think if you have tools and ways of demonstrating that speed, management will respond to data, and that's ultimately what happened in the case of the checkout icon, is that once we had the data that showed that HTML table was faster than the image, it was something that was actionable.
Curious if you guys have done any experiments where you've seen diminishing returns with respect to latency, like maybe replacing the Google logo with just plain text. So diminishing returns in terms of latency, meaning we actually tried to make things faster. Yeah, and lost users.
And lost users. Honestly, we really haven't. We have seen cases where we've increased the latency, and we have seen things drop off, like the experiment that I've shown. But generally, when things get faster, we see more usage. I'm sure there's a point where that actually would drop off, but we haven't run experiments that have shown that.
Hey, can you make AdSense faster?
We definitely want to try, yes.
For people who are doing a lot of monitoring for performance using things like Steve's episodes framework or something else that's trying to pull data out, the JavaScript's doing a lot of work to try and collect performance metrics that the browser already knows. What do you think about things like Chrome making available, time since last page click as a metric that can be pulled into the DOM so that we can get that back to monitoring systems? Because that seems like there's a real disconnect between the browser and the DOM there for performance.
I think that's a really good idea. And certainly, actually, one of the better ways that we measure latency is through our toolbar. So having something on the client side that can actually clock exactly when something's finished, not introduce more latency or more talkback time to the server, right then is actually, I think, something that's really important. And I think it's something that the Chrome team would be open to doing. So I do think that if we could reveal really good metrics like that as something that would incent people to make their websites faster.
Thanks.
Hi. So is the purpose of Chrome to develop a browser that will render rounded corners faster than square ones?
Maybe. It definitely is trying to make everything faster.
First of all, thank you for being here, given the crazy schedule and your travel. I'm sure I speak for everyone. We appreciate it. I was wondering, sometimes you redesign the homepage. I don't know, for special events, special holidays, do you pre-test for optimizing that redesign, or do you just kind of put it out there and see how it performs and then adjust as you go along?
It's interesting. We do just put it out there because it's become part of our culture. And interestingly, we don't really think of them as experiments, but that might have been a good answer to, have we seen cases where if we increase latency, I guess that's the same thing. If we increase latency, do we see diminished usage? There we don't, because I think the homepage becomes so novel that more people come to it, and a lot of times it gets blogged about and people want to come and check it out. But it is something that we measure, and we're very aware of how much that doodle slows down our homepage. And now we've actually begun rendering results page versions of the doodle because so many people are coming from the toolbar or from Chrome search boxes. So a lot of times people will miss the homepage, and we want them still to be able to experience the doodle. So we're doing a small one up in the upper left-hand corner of the results page. But it was really interesting, like getting to that outcome was about a 3 to 6 month discussion inside the company as to whether or not once every 2 weeks we could load a different logo and whether or not that would have too much of an impact because it isn't cached, on our users. And so we're giving it a try. I don't know how long it'll last. We're going to do it for the next couple of holiday logos, and we'll see how it goes in terms of overall usage.
The questions just keep coming. Can you talk a little bit about the next generation browsers like IE8, the Safari? What things are exciting to Google in terms of taking advantage of some of the optimizations with numbers of threads and things like that?
Sure. Well, I think that overall it's clear that browsers on the whole are becoming much faster and much more intelligent in terms of how they handle rendering, how they handle communication with the server, and a lot of the things that we've seen, like unnecessary flash rendering of tables, too many different connections open or slow connections being opened, strange handling of external JavaScript sheets. A lot of that is getting much better and much more optimized in those browsers. But one big problem is that the migration to those browsers is slow. We're still in a state where less than half of our users are on those fast browsers. And so really getting people to upgrade to fast browsers like Chrome or Safari is something that we would really like to see happen so we could optimize and design for those browsers that respond better to the HTML and JavaScript we're serving.
One follow-up to that. So when do you make those sort of decisions? What are your sort of thresholds?
Well, we measure the different browser ratios all the time. And certainly when you're dealing with the law of large numbers, you need to pay attention to groups of users that are even 5 or 10% of the population. So we really need to, what we generally try and do is optimize for, say, the majority of people, 50% or more, and then try and make sure that things don't break for users that are in these smaller groups. But we generally, in our web servers, will have a division for new browsers and for legacy browsers. And what we're really doing there is we will take some of the older browsers and move them into the legacy category as their percentage drops. So I think I have time for just one more question.
Oh, I was just wondering, with respect to Google mobile services, how does latency affect that, or have you guys seen differences versus the fixed web?
Sure. Well, there's no question that, one, mobile is growing really quickly, but two, mobile tends to be slow just because of the data rates to the phone. But we've seen some interesting outcomes. For example, we redesigned the Google homepage on our mobile devices, and we saw the latency drop by a good 5 to 10% using the new layout. And we saw an increase in searches proportionate to that. And so I think it's clear that there's things that can be done to overall optimize the platform as it currently exists. But when you look at phones that handle the mobile interactions better and faster, like Android, like the iPhone, in some cases the BlackBerry, we actually see a disproportionate number of searches from those devices because it's just much more feasible and pleasant to use search on a device where it renders in roughly the same speed it does on your computer. So we're seeing that segment grow.
Just a quick follow-up. Do you find you need to leave anything on the clients at all to optimize that experience? Like, can you leave images or graphics or static data to optimize that?
Well, for Google Maps for mobile, we do some of that. So, some of the Chrome is there and installed, and that's one reason why we're doing it as a client. We're able to store your home address and some of the map tiles that are near it. So the searches you do frequently or the driving directions you render of where you render from are already there and are really, really fast. So I want to thank all of you for having me here today. I have some HTML Wants to Be Squared t-shirts if you want to come and see me during the break, and thanks.